So in this video, we're going to go through two examples of identifying a region satisfied by a series of inequalities. So let's start off with the first one. X is greater than or equal to 0. So x equals 0 is this vertical line here. And because it's greater than or equal to, it's going to be a solid line. So it is just the y-axis there. Okay, so if we want, we could just draw another line over the top. Not going to make much difference to my axis. And then because I'm looking at greater than or equal to 0, so these are the values to the right of it. Again, you could try and substitute a value in, like x is 1. Is 1 greater than or equal to 0? Yes. So this is the region that we want, and we shade the region that we don't want. So we're going to shade to the left there. Okay, so you shade the region you don't want. Then if we say that x has got to be less than 3, this will be a dashed line, a vertical line at x equals 3. So dash line, like so. And we want it to be less than 3, so you could try a value like 0. Is 0 less than 3? Yes. So we're going to shade in the region that we don't want, which is going to be the region to the right. Then we've got y has got to be greater than 2. Now that is a horizontal line at y equals 2, like so. It's a strict inequality, so it's going to be a dashed line. Like that. And because we're looking at y values greater than 2, we would shade the region we don't want, which is going to be below. Again, try a value out. Is 0 greater than 2? No. So we want to shade the region we don't want. Like so. And then finally, y is less than or equal to 5. So this will be a solid line. Horizontal line at y equals 5. And because we're looking at less than or equal to 5, these are going to be the region below that we want. Try values out. So is 0 less than 5? Yes. So we want to shade the region we don't want, which is that. So what we get left with is this square here that's 3 long, 3 high. And so this is the region that we want, and we'll label that with R. Okay? So if you are shading the region you don't want, the region that you do want becomes clear because there's no shading in there. Okay? So that's example number 1. So example number 2. We have x is greater than 1. So that will be a vertical line at 1, and it's going to be a dash line. Okay, so x equals 1, something like this, dashed line. Okay, like so. And because we want greater than 1, we want the region to the right. Again, you can always check a value, so like 0, the origin. Is 0 greater than 1? No. So we want this region to be shaded, rather. That's the region we want to be shaded. This is the region we want. Now, y is greater than or equal to 1, so that is a horizontal line at 1. It will be a solid line because it's greater than or equal to. And we want the y values that are greater than or equal to it. So we want the region above. And so, like, is 0 greater than or equal to 1? No. So we don't want that region. Okay, so now we get to x plus y is greater than 3. So if we work out where the line crosses the x and y axis first, when x is 0, y is equal to 3. So that would be that point there. And when y is 0, x is equal to 3. So that would be that point there. So it's a line going through those 2 points. It will be a dashed line because it's a strict inequality. Okay. Like so. Now, what region do we want? We want it to be greater than 3. So substitute a point in that's not on the line, like 0. So 0 plus 0 is 0. Is that greater than 3? No. So we don't want this region here. So we so far got this bit here as our feasible region. Then we've got 2x plus y is less than or equal to 5. So again, if we do x is 0 first, then y is equal to 5. So that's that point there. And when y is 0, 2x would be 5, so x would be 2.5. So about there, I reckon. So it's going through those 2 points there. And it's a solid line because it's less than or equal to. Like so. And we want less than or equal to. So if I try 0, 0, it's 0 plus 0. So 2 lots of 0 plus 0 is 0. Is that less than 5? Yes. So the region I don't want is above. So this triangle that we have in here, this is the feasible region. It's quite small, but these are the values that satisfy all 4 of those inequalities.